Welcome to my channel. So in this tutorial, we will be proving the Weierstrass substitution. So it says that if t is equals to the tan of x over 2, then these equations will be satisfied. The first one is sine x is equals to 2t over 1 plus t squared. Cosine x is 1 minus t squared over 1 plus t squared. And dx is equal to 2 over 1 plus t squared dt. There's dt here. So how do you go about proving this? With this one, this is very useful because it is normally used to turn a very complex trigonometric integral into an integral that can be integrated using partial fractions or polynomial long divisions. So for instance, if you are given an integral like integral of 1 over sine theta plus cosine theta, sine theta plus cosine theta d theta. If you are asked to integrate this might become very difficult. But if you use a Weierstrass substitution, you are able to like turn sine. So let me put x's here for clarity. So if you are able to express sine x and cosine x in terms of t or in terms of like a polynomial, that will be very easy for you to integrate as compared to integrating the trig identities. So this is very useful because it allows you to turn a complex trig integral into an integral that can now you can use partial fractions or polynomial long division to tackle it. So let's see how we can derive these expressions. So I will claim this one. So first, we have sine x. We can use the double angle identity. So sine x can be written as sine x over 2 plus x over 2. 1/2 plus 1/2 is equals to 1. So x over 2 plus x over 2 is equals to x. So this one, using the double angle identity, we can have this one is sine x over 2 cosine x over 2 plus cosine x over 2 sine x over 2. So this simplifies to 2 times the sine of x over 2 and the cosine x over 2. So this is sine x from a double angle identity. So with this one, sine x over 2, from my previous video, we realized that sine of x in terms of tan of x is equals to we use squared, so this should be tan square x over 1 plus tan square x. We proved this in my previous video, so if you want to know how this is proved, you can go back and watch the video. And we also have cosine square x is equals to 1 over 1 plus tan square x. So all this were proved in the previous video. So this one, you can find sine x. Sine x will be equal to tan x over 1 plus tan square x in a square root. That is by taking the square root on both sides. We also have cos x here. Taking the square root on both sides is 1 over the square root of 1 plus tan square x. But we don't need the sine x and the cosine x. We need sine of x over 2, cosine of x over 2. But now we only have sine x and cosine x. You can just fix that by replacing x with x over 2. I can do this in yellow. So if we have this as our proof in the previous video, then sine x over 2 is tan of x over 2 all over the square root of 1 plus tan of x over 2 squared. Can just replace the x with x over 2. Similarly, cosine of x over 2 is equals to 1 all over the square root of 1 plus tan squared x over 2, like that. So we can express sine x over 2 in terms of t. Initially, t is equal to tan to the angle of x over 2. So it means wherever you see tan x over 2, you just replace that with t. That is the Weierstrass substitution. So sine of x over 2 is equal to tan of x over 2, which is t all over the square root of 1 plus tan square x over 2, that is t squared. Next, cosine x over 2 should be equal to 1 over the square root of 1 plus tan squared x over 2, that is t squared. So we have gotten an expression for sine x over 2 and cosine x over 2 in terms of t. We can plug them back into our expression for sine x. So we can just plug them back here. Sorry about that. So we are plugging them back in here. So sine x is equals to 2 times sine of x over 2 cosine of x over 2. We have sine of x over 2 in terms of t, cosine of x over 2 in terms of t. You can just plug everything in. So that should be 2. Sine of x over t is t all over the square root of 1 plus t squared times cosine of t. Cosine of t is 1 over the square root of 1 plus t squared. So sine of x is equals to 2t all over 1 plus t squared. So this is the expression of sine x in terms of t. And this is exactly what we wanted to prove. That is 2t over 1 plus t squared. That is sine x. We are there for sine t. We are not there yet for cosine t. We have to prove what cosine x is in terms of t. So let's do that. So cosine x is equals to what we did previously. X is x over 2 plus x over 2. So this one simplifies to cosine x over 2 cosine x over 2, that is using the double angle identity, minus sine x over 2 sine x over 2. Where does this one simplify to? This one simplifies to cosine squared x over 2 minus sine squared x over 2. Right. So this is our cosine x. But we already find cosine x over 2 and sine x over 2 in terms of t. We did that in yellow, which sine x over 2 is this, cosine x over 2 is that. So let's plug them into our formula for cosine x. That is cosine square x over 2. Cosine square x over 2, this is 1 over the square root of 1 over the square root of 1 plus x squared plus t squared. By squared, we square that minus sine x over 2. Sine x over 2 is t over the square root of 1 plus t squared. T squared. What do we get here? 1 over 1 plus t squared minus t squared over 1 plus t squared. And this one is 1 minus t squared over 1 plus t squared. And that is cosine x. So it implies that our cosine x in terms of t is 1 minus t squared over 1 plus t squared. So this is exactly the equation that we are asked to prove from the very beginning, which is this one. Last one is very easy. How do you find the x? You know that t from here, you know that t is equals to tan of x over 2. So you can find the x from there. We know given t to be equal to tan of x over 2, we can find an expression of x in terms of t. So that should be this one is arctan of t is equals to x over 2. So this means that x is equals to 2 tan inverse of t. Then we can take the derivative of x with respect to t. And that should be 2. How do you differentiate tan inverse of x or the arctan of x? That is 1 over 1 plus t squared. So this one is equals to 2 over 1 plus t squared. So our dx is equals to 2 over 1 plus t squared dt. And with this one too is proved. So this one is what we are asked to prove from the very beginning. Just this one. Yeah, so that is a Weierstrass substitution. This is very useful in integrating complex trig functions. So if you're asked to integrate something like this 1 over, or we have like cosine of x plus the sine of x divided by the cosine of x minus the sine of x. Dx. This may seem complicated to integrate, so we can just replace what cosine x is in terms of t, what sine x is, what dx is. Everything will be expressed in terms of t. You now have to deal with integral of rational functions, which you can either use polynomial long division or partial fractions to break the polynomial down. So this is a very useful substitution which was developed by Weierstrass in order to turn complex integral of trig functions into simple functions that can easily be integrated using partial fractions or polynomial long division. So if you find this video helpful, make sure to like the video, subscribe to my channel, and then I will see you in the next one. Thank you so much. Bye bye.